Welcome everyone. Great conference so far. And we are starting with our session about DevOps and mBank. And here is Piotr Stapp.
And Marcin Przekop. So, let's begin. Thank you. First of all, the new mBank, which we'll be talking about, and we are trying to talk. Oh, maybe one more question. Who is from Poland and maybe who doesn't know what's mBank? Everybody? One? Okay, so mBank is one of the biggest Polish banks, mostly known as an internet bank, and I hope we are the biggest one. What's more, we are built on the .NET stack. We use ASP.NET and MVC3. We have SPA application based on Backbone.js. So we are just a modern web development project. But there's one very small difference. We are really huge and complex. So the numbers. The first stage of the new mBank project was 6 milestones, 8 UI, UX dev teams, 18 months, 171 SLN files, almost 1,000 used packages, 5,000 JavaScript files, 1,200 C# files, a lot of versions of packages, much more downloads, and almost 5 million lines in CS, JS, HTML, and CSS.
Not generated, just real code.
The video which you are watching, it's GSource. It's visualization of our source control during the first stage of our development. So now, Marcin, about, one more thing. What's the more problems we had? Our project is multi-site. It's multinational because it's in Poland, Czech, and Slovak. It's multi-company. It's not always only mBank. It's also Orange Money Finance. There's a lot of companies which are included, like Accenture. We have multi-technology, multi-owner of the product, and that's our architecture.
Couple of words about the architecture of the mBank website. So we are focusing mostly on the website and the backend of the website. Well, it's pretty standard 3-layer architecture. So we have a couple of web servers. As far as I remember, it's currently 5. Quite powerful machines. 3 application servers and the backend databases or core banking solution, Altamira. What's important is like web servers are stateless. Application servers, they have a lightweight state, but it's shared between the servers. So the communication going through the layers, well, we cannot predict which route, which path it will take. It will matter later on. Communication is handled via WCF services, binary over TCP. We have control on both ends of the connections. The architecture is, well, it's pretty simple. It's not that big, but it's not one machine. So it gives us a lot of the problems. Well, about an application server, I would like to say it's microservices, but that would be an exaggeration. So I will call it a module-based architecture. But what's important, each module is based on around a business functionality, so like accounts, savings, loans, etc. It can be compiled, it can be hosted, it can be developed, it can be tested independently from all our other modules. And of course, it can be deployed separately. And that's the basic of the architecture that we will need today.
Okay, so let's go on. The CI tools which we are using. TeamCity as a continuous build, so we are building almost continuously. Jenkins tools we use on the development environments as installation tools because TeamCity was too expensive to use it as a build agent and installation agent. Moreover, we have a lot of custom PowerShell scripts. We will talk about them later. But how our environment looks like. First of all, there's an dev test environment which can be built and installed on every developer request. There's also an official test environment which is automatically daily installation proceed. Then we have a pre-production, which installation is manual on request, and production also manual installation request. Installation on production was rare. Officially, it was one for a few months, excluding hotfix, which hotfix was like few a week. But as a hotfix, I understand also a new functionality. Not only find a bug and repair it, but also deliver a new functionality, not as a big release. But all this, let's say, procedure just changed. We are trying to move to continuous deployment. But before we start talking about operations, we have to clean out our development. I will show you a small history about how we solve artifact sharing. Because a lot of errors are repeated despite of the technology. Ancient, so before 2000, usually developers start, I started like this. I put all the external libraries in my folder. It was JAS, JavaScript, DLS, everything. And put it in source control, compile it. The prawns, it works. It compiles everywhere. The minuses are version control system is really heavy. And the most important, trying to manage update of the one external module, it's really, really difficult. Then, in the beginning of this century, in the Middle Ages, there was first version of the Maven, first of all. We also developed something like Firut, which was kind of a very simple thing. We moved all the shared resources, all the build artifacts into the shared share of the Windows exactly, but still it wasn't working perfectly. First of all, it's difficult to say what's the latest version. Moreover, when we should get the latest version of the artifact. Once, every day in the morning, developers came and say, oh, I want the latest. Every build is too slow. On request, could be dangerous. Moreover, if we have latest version, it's difficult to find out if it's installation time latest version or build time latest version. Moreover, if a security fix, Microsoft sometimes have a security hotfix like 3001, and then it breaks all the builds. So, moving to the next epoch, Renaissance, a lot of dependency management tools was created, like NuGet. It's our trust, Maven, NPM, Bower, and so on. NuGet, we chose NuGet exactly because we are in the .NET environment. But NuGet have a lot of problems. The biggest one is that it have included in the solution file, project file, version our solution is splitted, so every project creates a package. We don't have one big solution with everything. We have a lot of 171 solutions, and we built a common artifact. So including in the source control the version of this package was a problem, because our main change every day was to update these versions. That's why we make a step forward, and from the nuget, we go to the REPL. REPL is an open source project based on nuget, which have two kinds of dependencies, float and fixed. Moreover, the version are declared in the solution REPL config file, and we can choose if we want latest, we want to have a version up to, and so on. But still we are using nuget packages, which is nice. When Microsoft fix nuget problems, we can move up. And as you can see, the main difference, there's no version in this file in the hint path. The future. Fortunately, in the VNext, so the next version of .NET, REPL ideas are implemented. So we can, I hope so, move up and use wildcards or empty for the latest version.
Now, a couple of words about how we handle configuration in our project. Again, the project is quite huge. The configuration is extensive, and we want to manage it as simply as possible. And what we'll focus on is I will try to convince you to, in some cases, use hard-coded stuff over keeping it in the configuration, the files. A little bit of history as well. So, how do we handle configuration? In the most common scenarios, well, we can just keep the configuration on the machines that our application is based on. So when we are deploying an application, we deploy all the binaries, all the stuff that comes with it, except the configuration. The configuration stays with the machine. As you probably know, well, it works, but that's not the best solution, as we never know what exactly the configuration on each machine is. And if it changes, we don't control it, how it changes. Okay, so we move from that. Let's keep the configuration in the source control. So we deploy it with all of our binaries, all of our packages, and we prepare the configuration up front, keep it in the source control, and deploy it in the machines. Well, that also works, but it has its own problems. Mostly it's because then we get duplicates of our configuration. So each environment has its own set of configurations. We commit it, and when we propose a change to the configuration, we have to fix all of those files. Well, that's usually manual work, and sooner or later, it will cause problems. So let's move forward. The third solution. Let's prepare, so we call it a template of the configuration, and then we keep separate files with the values that have to be put in the specific points of the configuration. You can see an example. On the top box, we have an example of the template. As you can see, there are special tags that start from $ and the name in curly brackets. That's what we call a token. A token is a place in the configuration that can change depending on the environment. So, for example, on the development environment, the app server name, it's probably going to be localhost. On the production one, that's probably going to be either an IP or a DNS name of our production application server or load balancer. The second box is an example of how we keep the values. So we do keep them again in files, in XML files. We commit those files to the repository, so we keep the changes and we track the changes. And we have a tool that fills the templates based on those configurations, those XML files, and generates the configuration per machine, per environment during the installation. And then the last box is just the filled configuration for this specific environment. That makes us independent from makes the configuration independent from the values that are changing. The tool that we are using is just a couple of PowerShell scripts. It's not a big tool. If you're using most common things like Chef, they have the similar idea. But if you don't want to take the whole Chef to your organization, you can start small. As a side note, we are already using Chef in some of our projects. But this one, well, the solution is Microsoft Stack, Windows-based. A couple of years ago, when we were starting, Chef was not working on Windows. So we had to develop our own solution. OK, so let's move on. Now let's talk about the code and the configuration. Let's take an example of connections. We have two servers, client and a server. We want to define the WCF connection between them. Usually, well, Microsoft provides all the things that you need to build the WCF connection. One of it is a huge configuration file that has, like, if you want to be specific and put everything in it, over 100 tiny details that you can configure and tweak, making your WCF connection. And we actually did that. We actually tweaked a lot of those. And OK, now we can put them in the config files and load them during the application start, and well, it usually works. The problems that you have with it is that from time to time, when someone changes something, for example, on the client side, and doesn't propagate the change to the server side, you will get a nasty exception calling a binding mismatch or something like that. And well, finding those changes is difficult. So what we decided to do, it was decided to simplify the connection. All the things that you actually need to connect to a client and the server, if you are controlling both of the sides, is actually you need a data contract, you need a server import, you need a path, and you need a binding type. That's the magic. That's how our connection definition in our configuration looks like. Just simple things that I said just a couple of seconds ago. What happened to all those 100 configuration points? They were hard-coded. So things like timeouts, things like messages sides, etc. They were hard-coded, and they come in the binaries to the client and to the server. Well, it does sound like a heresy. Why do I first abstract our connection and put all of those stuff in the configuration so it's more flexible? And now I'm saying, no. Let's put it back to the code, and if I want to change something, I have to recompile it and redeploy it. Well, if you think about it, why do we do that? Why do we abstract the configuration and make it so huge? Usually because we are afraid of the deployment. That's one. Or we actually need them, so they change often. But if something does not change often, and the deployment is carried on, we are not afraid of deployment anymore, then why not hard-code it? And it makes the support and everyday operation, at least in that part, a lot easier. Well, the pros and cons, most I've already told. Where the cons are, that's the most important one. Well, changes are difficult to propagate. So if I actually change something in the binding, that's the thing that hides all those configurations, then yes, I have to redeploy the whole solution. But how often does it happen? Actually, since we developed like 12 of those connections that carry the most typical situations, like HTTPS, communication, TCP, giving our endpoints for like Java or external systems. We have like 12 of those. And from that on, well, there was no need for it. And we hope so it won't be needed. But if it's so, we can deploy it. And it's a custom solution. So if a new developer comes to our company and sees it, well, he's a bit lost. So it takes some time for them to get accustomed to it.
Okay, so now the release management. Nowadays, there are a lot of well-known tools like Chef, like Puppet, in .NET like Octopus Deploy. Sometimes it's just custom Power or Bash scripts. We are on Windows. When we think about Windows and Chef or Puppet and Windows 2008 instead of the newest one, it doesn't work well, unfortunately. That's why, maybe one more thing. 10 years ago, when the first mBank was done, the idea of release management will be damn useful. Yeah, everybody thinks about it and deploy it, let's say, by hand. So you have to make, because the even Octopus Deploy doesn't fit our needs, we have to deploy some our custom small solution. There's a couple of PowerShell scripts which can set up website, Windows services, even SQL Server with analytic services, reporting service, or integration services, shares on execs on shares, and sorry. It's 5 o'clock, I should go home. Moreover, it generates config, and of course, download all the packages which the solution needs. The one more tool which was created a really long time ago, I was on studies when my boss created it was DB tool. There are a lot of tools now which you can use it instead of writing your own, but we have it, so we use it. It's the more well-known name is like SQL app. So this tool allows to recreate DB with patches. Moreover, it allows to track which patches was applied to the database. It maybe sounds stupid, but I have my own experience that I ask DBAs, admins like, hi, I know you have a backup procedures with 5 steps. I would like to add something between second and third step. Exactly in the second, it will be the best to make one more operation temporary for 2 weeks, but for the statistical data, it will be really useful. The answer was, the second step on the production is commented out. I said, what? So we just create some procedure, create it. I know that DBAs know what they are doing and probably have better solution, but we didn't have a feedback what they did. So sometimes automatically make provision of the DB allows to make a feedback from DBAs because they will have to do something with our scripts. Moreover, the process of the test environments, it's fully automated. What we are exactly talking about? It's a simple table in every database with the columns like patch ID, execution date, script, file, and last modification date. So we can exactly know which script was deployed on the production database. But we have to be careful because as a developer, sometimes I create scripts which can take 8 hours and roll back 16. Because I don't have enough knowledge to run it fully on the production. That's why probably our DBAs still don't trust it and want files. But we have exactly procedure how to make it. There's a small user operation in this process. Showing us this tool, I don't want to tell you that you should create your own. No, try to find out what's on the market. There's a lot of tools now, and try to use it. It will be useful.
Okay, now a couple of words about how we manage logs. Well, there is a difference between production environments and our test environments. On the production, we use the tool that's called Splunk. And, well, it's quite popular. The only problem with this is that it costs money, and it actually costs a lot of money. So what do we do when we want to handle logs and don't want to pay for it, for the testing environments at least? Well, let's look what the open source offers and use some of it. But first of all, let's take a look where the logs are actually, where are they logged? So they can be logged in event logged. That's Windows store for it. And most of our logs actually are there. Then there are files, normal files that everyone knows. SQL databases, well, and probably a lot more. The problem with our common logs is that first, they are inconsistent in format. So depending on the solution, depending on the destination, they can have different, for example, dates, different formats of dates, different formats of categories, identifiers, etc. We have to match the logs from the different sources. The other thing is all of our logs are a different purpose. The most important one is an audit log. As we are a bank, we are obliged to keep a log of user activity on the site, well, at least the operations that he's making, because of the law that's in Poland. Second type of the logs are, of course, the performance ones. That's normal. And a developer logs. So this one are technical. I mean, every developer can have an opportunity to log the activity that his application is going through. Not only errors, but as well like information logs. And as we showed you before, our application is distributed amongst many machines, and we don't know which route the message will go through it. And as I said, well, we looked for the open source solution, and there is actually a very good one. It's called ELK. It's an acronym from Logstash, Elasticsearch, Kibana. Those are 3 tools. All of those are open source and free. The owners of those tools started as a separate project, but very, very soon the community showed the possibility of combining them to make one huge system. And the authors of those logs are actually now working very closely together. So when you get the Logstash, Elasticsearch, and Kibana, they come with the predefined configuration that allows to connect them together. So let's go through them. What's Logstash? Logstash is a tool for data collection, parsing, and enrichment. What does it mean? It means that it will take a log from almost any source you can imagine, parse it, and make some operations on it, like changing formats or categorizing or adding some additional fields to those logs. And it makes them consistent. Elasticsearch is a database tool, you can call it. You put the logs in it, and it provides you a very efficient search and analytics over it. And a Kibana? Kibana is a data visualization tool. So it connects to the Elasticsearch, runs the queries on it, and visualizes the data as tables, graphs, diagrams, etc. We also use one more tool. It's called NXLog. and it's a lightweight data collector. So you can use Logstash and install it on any machine that you want the data to be collected, for example, from the event logs. But Logstash is a Java application. So when you start it and it works for a little bit, it can get to like half a gig even memory. And some of our machines in our low environments are very light on memory. So we could not allow it to take half the gig of it. So we took an NXLog. It's just simple. It's a simple tool. It's like 2 or 3 megs. And its only idea is to get the log and pass it to Logstash, who's installed in the central server. Okay, let's take a look at actually looks like. That's a demo from our log viewer. That's a Kibana. That's a third version of Kibana. Actually, about 2 months ago, there was a version 4 that's available now. You can download it. The idea is exactly the same, but the technicality changed a lot. The new one is Node.js, and you cannot simply port your dashboards from the 3 to 4. That's why we still did not migrate it, but we consider it. So that's how the developer can see his logs when he's going through the environment. As I said, for example, let's think about it. We have to analyze the error that's come to the client. We got the bug report in our SRR tool. We look at it. We only see a screen from our application, and we need to find the log. Usually what we had to do, we had to go through all of the machines and check the logs in files, in the event log, in SQL database. Now we can just find it in the tool. That's a demo. These are the demo data. So of course it's not for any production or test environments.
On production server, so it doesn't have any error.
Yeah, that's true. These are some simple graphs, so we can see the environments. Here I have development and test environment. I have all of the errors and informations across the data stream, the time stream, I mean. Here I can filter the errors based on the components I have installed. For example, here I'll have an account component from our website, and AFT, that's a back office application. So let's see, I can filter the data, and here I can see the logs from across all of the machines and all of the sources. And of course, I can see the details of each of the log. It provides me a query syntax as well. I can use regexp or I can use Lucene query syntax. So let's see if I can find message error. And I got the message filtered. How long does it take to move your company to using something like that? Actually, it's quite a funny story because we did a similar presentation a month ago. And after the presentation, one of the guys, attendees, came to us and asked about the solution because he wanted to introduce it in his company. And actually, we got an email on Friday that he did it. So it took him a month for one person to go through the solution to all his logs. And his solution is actually quite large because it's based even on geographies, not only on one site location. Only like making it work. So running Logstash, Elasticsearch, Kibana is really simple. It takes a day. The problem starts when you start to parse the data and analyze them and categorize them. Then some work needs to be done. But still, the effects of it are tremendous. And the developer that analyzes the errors or logs or complaints gets a lot easier task than it had before. Okay, let's go back to the presentation. Actually, that's all we had prepared for you. So if you have any questions to the presentation or overall, please ask them now.
So how do you guys version your WCF contracts?
That's actually a good question. What we do, we keep it in code. So all of our contracts, the interfaces at least, are moved to a separate assembly, separate DLL, and this assembly is shared between the client and the server. Of course, if we control both of the sides. So we are not using whistles or anything like that. We keep them in code. Of course, those DLLs are lightweight. They have no external dependencies of anything like that. Only the contracts and, for example, the data that is passed, the structures. And they are, of course, they are in code and committed to the repository, etc. And what's actually also important, all of our all of our projects, so each assembly is packed to a single NuGet package. And we have a central artifact repository that gathers all the package from all the compilations. And the same packages are used for other projects, so they can go there and get the compilation, get the artifacts from other projects that they are needed for their own compilation. And the same artifact repository is used later on to build the actual like testing environments or production environments.
Chciałem spytać, jak dużo danych trzymacie w Logstashu, Elasticsearchu, jaki jest przyrost tych danych w ciągu, powiedzmy, doby, jak to się skaluje generalnie?
The question was, how much data do we store in Elasticsearch every day? I don't know the exact number, but so far we didn't have to purge any data, and it's working for over a year at the moment. It's a couple of gigs, but we don't store, for example, the IIS logs that are huge there. And we don't store the production. It's only the testing environments that we are storing. So it's a lot less volume that you would expect in production. As I said, on production, we use Splunk, which is a paid tool. No, it's a couple of gigs a month, maybe. But as I said, we are not putting the IIS logs there. Then it would be a lot more. Our logs, it means only the files that we are logging. Well, they are like a couple of megs per application per day. So it's like 100 megs per day from those. And event logs, those are actually even less. So it's, let's say, 100 megs per day, not more. Probably less, depending on the usability of the environment. Well, if you think about it, the question is why we do have so many solutions. First of all, we wanted to...
If I have a microphone, maybe me. It was easier. When we start, the old mBank site was the one solution. And we have a joke, we have one solution, one database, one developer, and one file. Usually, big solutions in Visual Studio doesn't work well. It's probably in Eclipse, big solution in Java also doesn't work well because they are big. When you are a developer of the single module like loans or payments or whatever, you need a functionality of your own. The rest of the functionality you can host somewhere else. You don't want to change the functionality of payments when you are developing loans. You need only to use it. So the small solution allows to fast delivery and fast working on the developer's machine. That was the main reason of making a lot of small solutions instead of one with 100 CS pros.
The simple compilation of those huge solutions that we had at the beginning took almost 2 hours. If you changed a small piece in it and ran the compilation, it took like 3 minutes. So you cannot work with it.
So what's the reason behind keeping different logging solutions for testing and production, apart from the price of Splunk?
Well, in this case, the price was the most important fact. No one allowed us to buy Splunk for those yet, at least. But now we don't need it. But when you think about it, well, it does not matter that much. It's just a log gathering solution. We actually log in the same way on production and on the test environment. It's just a tool that gathers the logs is different. And most of the developers don't have access to the Splunk anyway, because there are some sensitive data in it, probably.
Maybe one more thing, because Marcin didn't say it. The reason why we keep logs of the developers and test environments is that sometimes we need to diagnose what's going on. Usually we want to reproduce the error somewhere in the, let's say, test environment. Having history of the logs for the 1 year or something like this allows us to search for such bugs on the test environment also. The difference between Logstash and Splunk in the interface, it's so small that normal developer doesn't see any difference. The searches environment, search strings are almost the same. So we want to have one, let's say, maybe one more thing. Why we use Splunk on production? One thing is money, but the main reason is that Splunk allows to have access rights implemented, implemented inside. The Logstash doesn't. So if you allow somebody to see the logs, he will see all the logs. In Splunk, you can allow him to see only the part of it which developer need. Not every developer should see all the logs. I hope we are talking about money, so it's clear why we don't want to share all the knowledge to everybody in the company. So thank you very much.
Thank you.